Hello everyone, welcome to Understanding Physics, in which I will try to guide you through understanding physics. So in here I want to try to discuss about the foundational mathematics that you need to go forward in your journey in science as well as in engineering. So this series will cover lots about differential calculus, integral calculus, multivariable calculus, in complex numbers as well as linear algebra and all of those. So without further ado, I want to discuss more about each of these topics. And if you want these videos to be notified to you, please consider subscribing as well as liking the video and click on the notification bell. So first of all, I want to introduce the book that will be the guideline for this entire series, which is the basic training in mathematics. And this is written by R. Shankar. So all of the sources here goes back to basic training in mathematics. So so if you want more detailed explanation of each of these subjects, please consider reading the book that R. Shankar made for me to discuss with you all. So let's just actually go through what we'll be discussing for this entire series. So this series will be separated into 10 different chapters. So the first will be about differential calculus of one variable. So this is where single variable calculus comes in. So in this chapter, we'll be dealing with lots of different functions for us to analyze to figure out where does the formula come from. And this is where we will discuss all all of the functions that we'll be using throughout science as well as in engineering. So after that, if you are used to doing differential calculus, we'll be dealing with integral calculus. So integral calculus basically tells you about the inverse of the derivative. And so we'll be discussing about some basics in integration as well as some tricks that you could use for integrals. The 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 third part will discuss about calculus of many variable, or sometimes you could call it as multivariable calculus. So multivariable calculus is very similar to single variable calculus, in which instead of having one single variable for you to integrate or do a derivative, instead we will actually be dealing with much more variables. It could be independent, it could be dependent, but in the end we want to try to understand multivariable calculus at its core. And we'll later also discuss about one type of units, which is the solid angle, in which not most of us actually know, in which it is also called as the steradian, which is the unit that is very similar to the radian. So that's about multivariable calculus, in which we will later discuss. And then after that, we'll be dealing with infinite series. So why do we need to understand infinite series itself? So infinite series gives us a basis for us to do differential uh, differential equations, as well as many other functions in which we don't know what the answer is. So something like the gamma function, or maybe even there are some other functions that is given as a series. So you would need to know when will the series converge or diverge. And so if you know that something is absolutely convergent, you could use it to approximate what the value is. And so this is one of the core things for you to know when dealing with science as well as in engineering. So in here we will give you some test for convergence, as well as we'll give you some power series. One of them is the most known power series, known as the Taylor series. So after that, we will later be dealing with complex numbers. And so complex numbers is is where you have imaginary numbers as well as real numbers, add add them together. You would have something which you call as a complex number. And so you could write this in the Cartesian form as well as in the polar form. And you will later see what is the use when you actually deal in what you deal in electrical engineering, where you discuss about the the impedance of a circuit. So it is important for you to understand complex numbers as well, even though that it might be a little bit abstract. And so after that, we'll later deal with functions of a complex variable. So we will later give you a function that could take in complex number to give out another complex number. And some functions are analytic while some don't. So we'll later discuss a little bit about analytic functions themselves. The seventh chapter will deal with vector calculus. So vector calculus is where you will later do calculus, but instead with vectors. So you might know from the for example work. Work in physics is f dot ds, in which ds is a vector. So you would need to know how do you actually do these kinds of calculus. And and this will later also exist in the Maxwell's equation as well. So you will later deal with gradients, with curl, with divergence, and all other stuffs. So after we have talked about vector calculus, we will later talk about matrices as well as determinants. So this is the basis of linear algebra, in which you will deal with a bunch of systems of equation, that a linear system of equation in which you can transform them into into a into a data of number that you could manipulate to figure out the answer. And so matrices and determinants are normally used in computer systems. And so normally computer science students need to understand about linear algebra, but also electrical engineering also use matrices to solve circuit circuit problems much more faster, since most of them are linear components. So it is very useful for you to know about linear algebra in any fields. And it might be a little bit abstract as well, but I can guarantee that it will be useful once you deal with certain kinds of systems. So the ninth one would be about linear vector spaces. So this is where we will exactly define what a vector is and what are the rules that we need to follow when dealing with vectors. So this is a very abstract idea, but this will later be useful once you actually deal with the eigenvalue problem as well as tensors, which is one of the core things when you actually deal with the mechanics of material in which you will be manipulating a tensor. And so lastly, we'll later discuss about differential equations. So something from the ordinary differential equation, an ODE equation. Something from the ODE until a PDA, a partial differential equation. And so we'll later discuss the wave equation as well as the heat equation, and we'll later discuss about certain methods that we'll later use to solve differential equations. So this is the entire series that we'll later discuss in foundational mathematics for science and engineering. So I hope that the series will later help you to get a firm understanding in mathematics for you to understand physics. So thank you very much, and if you want these videos to be notified when they are uploaded, please consider subscribing, liking, and click on the notification bell to get the notification that the video has been uploaded for you to watch as soon as possible. So thank you very much, and I will see you on the next video.